Hello and welcome to my video lesson 1.4 on 2D collisions. The only thing that is really new here from the conservation of linear momentum is that now we are talking about vectors. We're talking about angles, 2D collisions. So we're talking about trigonometry, Pythagoras theorem, and SOHCAHTOA. So we have to conserve not only the momentum, but we really need to consider the vectors of the momentum. So the directionality of momentum from beginning to end. So if the momentum at the beginning is only to the right, the momentum when you have the final vector is only to the right. So it's the same idea as in the last video, pi equals pf. But when you break this up into component vectors, I recommend that you start your equations instead of just like in the last video we just did this. Right, we had PAI, PBI equals PAF, PBF. That's fine, but now we're basically doing it twice. We're doing it in the x direction, and we're doing it in the y direction. So we're now having two equations, that is basically double the work as before, in order to solve these same sort of questions. Okay, so the momentum is conserved in the x direction, or the horizontal direction, left, right direction, east, west direction, whatever. And the momentum is conserved in the y direction, vertical, up, down, north, south, whatever. Oftentimes, many of these terms may be zero if the velocity at a given moment is zero, and that means you can cancel out the term before continuing to solve. That zeroing out thing is so useful, it just speeds up the process instead of having to write it all out. It's the same skills that you would have used in Science 10 and also especially Physics 20 in the conservation of energy topic. So take a look back there if you need to get a little bit of a recap. But here in this example, two cars collide, and yeah, we're going to start trying some of these examples. Also, I'm looking at it, and I don't have the numbers correctly, so I hope this one's ready to go. Two cars collide in the middle of a four-way intersection. They get stuck together and are moving after the collision. Okay, they cannot determine who is at fault in terms of going out of turn. However, they can determine, because both drivers claim to have stopped at the stop sign before moving. Driver A was traveling north while driver B was traveling east. The police investigators are able to determine that both cars were identical mass prior to the collision, and that due to friction, they were able to determine by how far they traveled. Their final velocity after the collision was that, together. Their final velocity together was that. Which driver was traveling faster and therefore lying to the police, and by how much? So this one you could just do qualitatively, except for the statement and by how much. So we're going to try it out and see if we can do this. So to start with, we have two cars colliding in an intersection. Since it is the driver A is going north, so let's just try to draw this out. So I'll just say this is A, and they're going north. Driver B was traveling to the east. Okay, so that's this way. Okay, and then once they hit, they go on kind of in this direction. It says north of east, so that means this angle here is 60 degrees. So let's just maybe go like this. Okay, there you go. So that is your 60 degrees there after the collision. So 8 meters per second. Okay, so the question is, they were able to determine that their final velocity was that after the collision, which was traveling faster and therefore lying to the police, and by how much. Let's see if we can do this. I know we can figure out who was lying to the police. By how much might be more challenging. We'll see about that. Basically, because we know the final velocity, we can kind of break this up. So let's talk about how we would do this based off of the formulas at the very top of the page now. So in blue, let's flip this around just because the colors are Gonna match up more nicely. No, that didn't work. Okay, so we're gonna do red first. Okay, red is the x direction. So PXAI, I'm gonna use capital A, I, plus PXBI equals PXAF plus PXBF. Okay, so that's what we're starting with. All right. Now in the x direction, only the B in the initials, only the B has an x direction to start, right? Oh, actually, and better yet, we don't even have to do x, A, and B separately. This will be x, T, I, because they're going to be together at the end. Okay, so it's going to be one mass in green that leaves at the end. And we know that the A value does not exist because A only has a Y value or Y component, so it's actually going to be PXBI equals PXTI. All right. Now let's try out the Y direction. So this is still going to be the same sort of thing. PYAI plus PYBI equals PYTF. Oh, and I put I's before. I made a mistake. This should be an F. This should be an F. Okay, so now in blue, now you can see that A does have a Y direction, but P does not have a Y direction, so P actually will disappear. So instead we're going to have PYAI equals PYTF. Okay, now we have these formulas which will tell us the original velocity for B and the original velocity for A. Alright, so let's go ahead and see if we can figure out what the PXTF is going to be. So the x direction for P is going to be over here, the x direction over here. This is going to be the y direction for T. This will be 8 times the mass of A times the mass of B cos 60. Now we don't know the mass of A and B, but we know that they're actually going to be the same. So instead of writing them out like that, it'll be 2 times the mass, right? Because it's mass of A plus the mass of B, so if they're the same, it's going to be 2 times the mass. Same thing over here, it's going to be 8 times 2 times m times sine of 60. Okay, so this is all fine and dandy. Let's go ahead and plug that into these formulas here now. So we have, actually this one will be MVBI equals, and this is in the x direction, so this will be 16 m cos 60. Now what you're going to see if you divide by m, they're both going to cancel on both sides. So VBI equals 16 cos 60. And let's do it on the other one. So this will be MA, but A is just the same as B, so it'll just say M. AI, equals, and then the momentum of the total, which was the y direction, so 8 times 2 is 16, times by m sine 60. Now again, the masses are going to cancel, so we're going to be left with VAI equals 16 sine 60. Okay, so with all that said, we're going to have 16 times cos 60, which means that the person, person B, driver B, was driving at a velocity when they collided of 8 meters per second. Okay, and person A was traveling at a velocity of 13.8 meters per second when they collided. So it's possible they both were lying to the police, because 8 meters a second is fast enough. But let's just quickly convert that. So 8 times 3.6 to get us the kilometers per hour. Okay, not too bad. You can speed up from a stop sign. It's possible. 28.8 kilometers per hour is possible from a stop sign to the middle of an intersection, although they were slamming on the gas. But let's take a look at the person B. 13.8 times 3.6. Yeah, from half the intersection, they were able to get to 50 kilometers per hour. So, person B was going way too fast to make that true. You can't go from a dead stop to 50 kilometers an hour within half an intersection. The other person maybe slammed on the gas, but the one person blew through a stop sign. So person B was at fault. Maybe they were driving past the speed limit and then slammed on the brakes the last couple seconds, but didn't quite slow down in time. Yeah. Okay, let's take a look at another example here. This is going to be just kind of a different type of example. So the last one, they stuck together, and so that makes it one type of question. Here's another type of question. When bowling, the average speed of the ball is that, almost 8 meters a second. There's the ball's weight. If it collides with the pin that is deflected off at that speed and direction off center, what is the final velocity of the ball? Okay, because the ball weighs way more, right? It has more mass. It's going to be less affected. But you can see here, this is kind of a picture of what's happening. Okay, we're just changed the direction here, but we're going to have the ball come in at this angle, coming in like that, coming in at the side. And then the ball is going to get deflected this way, right? Which means it's going to have components in this direction. Oops. Okay. Also, the pin was deflected off in this direction. And it tells us that it is 70 degrees off of center. So I'm actually going to choose to put it down here. I prefer to have my two triangles further apart so I'm less likely to make a mistake. So I'm going to call this 20 degrees. Alright, so here's the setup. Whoops. I'm going to just erase a little bit here so it's a little bit easier. Here's the setup. Now let's start with the different equations. Okay, so the equations are the regular kind of situation. Oh, whoops. Make that smaller. The regular ones are going to be PXA. I'm going to call my ball the A and the pin B, just by the way. So PXAI plus PXBI equals PXAF plus PXBF. I hope that it's not too fast, but we'll see how that is. I think it'll be okay. Otherwise, something weird might happen where the ball comes backwards, but hopefully that doesn't happen. Okay, so anyways, this is the setup for the X direction. Now we're going to try the Y direction. So PYAI plus PYBI equals PYAF plus PYBF. Okay, so there's the setup for both the x and the y direction. Now at the beginning, there is no b value. So that's just going to disappear, and actually we can say the same thing for the y direction of the b value. And we can even say at the beginning that there's no y direction for the a value because it's only going horizontally. Okay, so we can do that here. Now we can go ahead and rearrange and solve for what we're looking for. What are we looking for? We're actually looking for the ball's velocity at the end. So what we're looking for is, first of all, the y, and second of all, the x direction of the ball. Okay, so the final pxaf. So let's solve for that here. Pxaf equals pxai minus pxbf. In the y direction, it's the same sort of thing. Pyaf is what we're looking for. Pybf is what we have. Now, we don't have those momentums directly quite yet, but we do have different masses, and we have different velocities, and we have an angle. So we're going to find those things. So first of all, the MAVAI is whatever we started with. That's going to be our PXAI. That is where that's coming from. Okay. Secondly, the PXBI comes from a component of the PBI, or F, sorry. PYBF is going to come from the vertical component of that one as well. So let's go ahead and start to plug all these things in. PXAF equals, now we'll write in MAVAI minus the horizontal component, which is going to be the sine. I should put that in blue. This is going to be the sine function of 20. This is going to be the cos function of 20. So anyways, this is going to be MBVBF sine 20. Okay, and then the other one here in blue is going to be PYAF equals MBVBF cos 20. And it's actually going to have a negative. Forgot to put a negative there. Okay, negative just shows that it's up instead of down. Okay, so now we have our two different momentums, the x and y components of our momentums. What you can do here at this point is actually we could solve directly for the velocity components. So we could divide by ma, or we can continue to the actual like final solution. We could kind of do this differently. Yeah, let's do it the regular way. What I'm going to say is the regular way. Okay, so we're looking for the theta here, and we're also looking for the c part. So the Pythagoras theorem gets us c. So for c, we're going to have that equal to, so c squared equals a squared plus b squared, or c equals the square root of a squared plus b squared. So this is a, which I'm going to call the x direction. So MAVAI minus MBVBF sine 20. So that's one of the values. And then plus negative MBVBF cos 20 squared. Now this negative will disappear because we're squaring a negative, so that you're just going to have to deal with the direction later, which is okay because that's what the theta is there for. And just keep in mind, when we solve this, this is actually not our final answer because we're looking for the final velocity. So just make sure that you divide by mass to find your velocity. Momentum divided by mass is your velocity. So whatever C was, it's going to be C divided by mass of ball A, and that will get your velocity of A final. Okay, so we're going to do that in a second, but before we do that, let's set up the theta. Theta is tan -1 of the opposite, which is the x direction, which is the x direction there. So mass A, velocity A initial, minus mass B, velocity B final, sine 20. That's our opposite. And our adjacent is mass B, velocity B final, cos 20. And generally, I honestly wouldn't include the negatives. The negative just tells us that it's up. So negatives aren't really important here. So that should work. Okay, so let's just plug it into our calculator now. The square root of mass A, which is 5.56 times velocity of A, which was 7.82, minus, I'm just trying to keep track of everything, 1.54 times by the velocity of B, which was 20, and then it's sine 20, and then we square that, plus, I'm not going to include the negative because it's squared, so it disappears. So 1.54 times by 20 cos 20 squared. Okay, so this gives us that C is 43.85 over the mass, which was 5.56. So divided by 5.56. And we get a velocity of, yeah, it's going to bounce back and do weird things. I made my pin go too fast, but it's okay. It doesn't make sense physically, so on a test I would make sure that my numbers line up a little bit more nicely, but it'll be fine. Because it couldn't have sped up, right? It doesn't make any sense for it to speed up, even if it's going a different direction. Like, you've added energy into the system, so that doesn't make any sense. But that's okay. We'll ignore that. Okay. So, anyways, let's continue on with tangent. So tan -1. Again, sorry, this is not going to make sense. So that actually is going to mean that we're going to have this going off like backwards. So this is going to be very interesting here. So 5.56 times the velocity initial, so 7.82 minus 1.54 times by 20 sine 20. This will be 1.54 times 20. Oh, did I do sine 20? Oh no, I should have done sine 20, yeah. Because I did 70 before. Okay, so yeah, sine, so this would be times cos 20. Okay, 48.7 degrees off in that direction. So there's no way, like this doesn't really make a whole lot of sense because we've sped up and you can't add energy, so we have created energy in this question. But in terms of the momentum part of it, this all does make sense. and actually this would be in the direction that it says, so this would be east of north. Alright, I know this is going to be a long video, but 2D vectors just takes a long time, and I want to give you as many example problems as I can. So here's one more example that we're going to try out. When playing pool, two identical balls collide and then fly off in different directions. This is basically like one that we did in class today. If you watch this in the future, I may or may not do this example in class. But anyways, these balls fly off in different directions. Ball A has an initial velocity of 1.05, 35 degrees south of east, while ball B, blah, 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 blah. So basically what's happening, let me just explain this, it'll be a little faster. Basically we've got two balls. We've got ball A coming in like this, and we've got ball B coming in like this. Let's label the directionality of it. Ball A is going south of east, so A, if this is east, this would be south of east, so 35 degrees. Okay, and ball B is going 25 north of east, so this would be 25 degrees north of east. Whoops. Okay, so the balls come in like this, okay? Then it says, if ball A ends up leaving with 0.87 meters per second, 50 degrees north of east, what is the final velocity of ball B? So this would be like this, leaving off in this direction, okay? And it's north of east, so that would be 50 degrees here from the center line. Okay, now it's going to be a little bit annoying in terms of space to draw everything, but you're going to get the right idea anyway, I hope. So this is going to be going off in this direction. Okay, and we're going to need to find the two components for ball B. So we need to find the BF in the Y direction. So maybe normally I would go YBF and YBX. No, said that wrong. XBF. There you go. Plus, we're also going to need to find the theta over here. So we're looking for a few different things. Let's just talk about it now as the formulas. So in the, let's go over here. So in the x direction, so P XAI plus PXBI equals PXAF plus PXBF. So that's all the things in the x direction. And there is an initial x in the A with the A ball. There is an initial x with the B ball, and there's also a final x for the A and for the B. Okay, let's do the same thing again, but in the y direction. So P YAI plus PYBI equals PYAF plus PYBF. Again, initial equals final in the y direction, and all of them exist. So A has an initial and a final y, B has an initial and a final y. Okay, now let's take a look. The two balls are identical, so this is important, so I'm just going to call it M, not MA and MB. And then also, what are we looking for? So we're going to be looking for the X for B and the Y for B. So let's first of all rearrange this. So it's going to be PXBF equals PXAI plus PXBI minus PXAF. Doing the same thing here, it's basically the identical step. So PYBF equals PYAI plus PYBI minus PYAF. Basically, we just subtracted the AFs to the other side on both questions, both equations. Okay, now what we're going to do is actually solve for the... Let's actually solve for the straight up velocity. I think it'll be easier for us if we think about that. So we're going to go like this and put in all of the different actual values. So V, okay, so this is going to have to be X. So instead of just doing A directly, we actually need to now start considering the cosine and sine function. So this would be the cos up here, this would be the sine, right? This would be the cos, this would be the sine. This would be the cos, because it's next to, this would be the sine function, this would be the cos. Oh, no, these ones don't matter, because we don't have them yet. So, anyways, going back down, this will be cos of 35, because this is the initial in the x direction, plus mvbi cos 25 minus mvaf cos 50. Okay, now what you can see is that there's actually an m in all locations. So the m's can actually cross out already. And so we're going to be left with VBF equals VAI cos 35 plus VBI cos 25 minus VAF cos 50. Same sort of thing can be done in the y direction. So this is going to be MVBF equals, I guess this should be YF, and this one should be X. But anyways, this will be MVAAYI, I guess. Yeah, this is kind of annoying with all the different letters, but there you go. This will be sine 35. Oh no, this will not have the y. This won't need the y, because we already are doing the sine. So that's what's getting us the y. So sine 35 plus MVBI sine 25 minus MVAF cos 50. Now you're going to see here that the m's cancel everywhere. If you divide by m, it disappears everywhere. So VYBF equals VAI sine 35 plus VBI sine 25 minus VAF cos 50. Whew. Okay, we're getting there. So now that all of this is in there, that tells us the two different components of our final velocity, because you'll see that the mass cancels, so it gives us our final velocity. So now we're going to look for the, I'm going to redraw that triangle, okay? I'm going to draw it over here. Okay, and down. Okay, so in the x direction, that's our VXBF. In the y direction, that's our VYBF. Okay, now we can just use those two values and use SOHCAHTOA to find the c. We can use those two values and use theta to find the, or tangent to find the theta. So c is the square root of a squared plus b squared. I'm going to choose to actually calculate these because we're going to use it in two different locations at the same time. So it's kind of pointless to do both. So let's go ahead and start calculating some of these. Where's my mouse? Okay, I want to get a little bit more room, or be able to see a little bit more, I guess. Okay, so we've got VAI, which is the initial velocity for A, which is 1.05, times by cos 35, plus the other initial, which is 0.75. Oh, that didn't do what I wanted. I need to close the bracket there, so plus 0.75 times cos 25 minus 1.05 times, nope, it's not going to be 1.05, it's the final. So now this is going to be 0.87 times by cos 50. So this gets us our B value, which is, so VXBF, which is 0.98. We're going to keep the sig dig, so worry about that part later in the east direction. So we're going to worry about the sig digs in a little bit later. Now let's try the same thing again, but we're switching it all to sine functions. So I'm just going to literally go in and just adjust that to sine functions. Everything else is the same. So VYBF equals 0.25. I'll leave it there, but I'm going to keep all the sig digs. And this is south. Okay, so now that we know those two, now we can plug them into the C squared equals A squared plus B squared calculation. So it's going to be like this. And then this number squared plus this number squared equals, so I'm just going to say 0.98 squared plus 0.25 squared, and we get 1.01 meters per second. Okay, now let's look at the tangent situation, which is going to be a similar sort of thing, but we're doing opposite over adjacent, so it's going to be the y values over the x values. So it's going to be this number over this number. Like I said, we want to keep all of our sig digs, but it's going to be roughly 0.25 over 0.98. So we're going to get 14.45 degrees. Okay, and so what we're going to say at the end is that this is, so how many sig digs do we have? 2 sig digs everywhere? Yeah, a lowest of 2 sig digs, so 1.0 meters per second, 14 degrees south of east. As our final answer. Alright, I hope that video helped you better understand 2D vectors and hopefully practice a few of them. I know this is a long one, but I hope it helps. Please take a close look at whichever lesson or examples that you want to. Hope it helped, and good luck.